Hey guys, welcome back. Today we are going to discuss basic information related to formula of an ionic compound. So the heading will be formula of an ionic compound. All right. Now, for example, whenever we are talking about formula of an ionic compound, basically a student should know this thing that formula should tell about the composition of that compound. A formula is telling that which type of positively charged ions and which type of negatively charged ions are combining with each other. Okay. So, for example, in case of sodium chloride, how to make the formula? Look at here. It is sodium and it is a part of group number one. It has a charge of +1. Okay, done. What about chlorine? It is a part of group number seven. It has a charge of -1. Is this a fixed value? Yes, this is a fixed value. These are the charges which are associated with these groups and these are fixed. So we have discussed this thing already when we were practicing ionic compounds. Look at this now. It is a cross multiplication of the numbers here. Simple cross multiplication. Okay. So one will come here and the one will come here. So it is just telling you that Na and Cl are coming in 1:1 ratio while writing the formula. Okay. So in this case, this is done, and now I'm going to share another example with you. Before moving ahead, I would like to inform you that whenever we are writing the formula of an ionic compound, positively charged partner, the metallic partner should come first, whereas the negatively charged partner, the non-metallic partner should come second. So sodium chloride, sodium is the positive partner, whereas chloride is the negative partner. Calcium oxide, calcium is the positive partner, and oxide, the oxygen, is the negative partner of that compound. Okay, so formula of an ionic compound is also called as formula unit. So formula unit is basically a unit which is telling us a very basic identity of that compound. It is telling us the basic composition of that ionic compound. So here, for example, I am saying this is calcium and this is calcium oxide. How they are going to make this formula? Look at here. It is group number 2. We should know this thing, that in which groups these elements are existing and what are the charges associated with those groups. So for that, we must have a basic information related to our previous knowledge, previous lectures. Now group number 2, so it has a charge of +2. Okay, and it is a part of group number 6, so it has a charge of -2. Okay, so -2 and +2 are cross multiplying with each other, so 2 will here and 2 will here. We are not changing the positions of the plus and the minus, we are just talking about the numbers. Okay, so 2:2 means 1:1, that's why they are coming in 1:1 ratio and CaO. All right, now we are moving on to the next board and I am telling you another example. For example, there are certain radicals. Before moving ahead, I would like to give you an idea about radicals or polyatomic ions. Now, first of all, a student should know this thing, that what is an ion. We have discussed about an ion, a charged particle, an atom. Okay, an atom of an element having charge is called an ion. Okay, and that we have said that positive or negative. Okay, so this is another story which we have already discussed. Okay, afterwards I am telling you that there is a type of ion which is called as polyatomic ion. So monoatomic ion is an atom, you may say. Monoatomic ion, so it is an atom of an element having charge is called an ion, and that is called a monoatomic ion. Whereas what about the polyatomic ion? Polyatomic ion. Okay. So it is a combination. It is a combination of two or more than two atoms of elements having collective charge is called polyatomic ion. All right. Now I am changing the board so that you may have a very clear idea about the polyatomic ions. Guys, there is a list about polyatomic ions. Polyatomic ions are also called as radicals. It is much better to keep that list in your mind. If you will keep that list in your mind, things will become much easier for you. For example, this is carbonate, CO3 2 minus. I will write down the names of all of them. But right now, it is the formula, for example, first. Here I am trying to make a table. Okay. So the first one is carbonate, and then it is HCO3 1 minus. It is called as bicarbonate or hydrogen carbonate, bicarbonate, or it is also called as hydrogen carbonate. So please be careful about this as well. Then it is SO4 2 minus, which is called as sulfate. Then it is SO3 2 minus, which is called as sulfite. Then it is NO3 1 minus, which is called nitrate. Then NO2 1 minus, which is called nitrite. Then it is PO4 3 minus, which is called as phosphate. Then it is NH4 plus 1, which is called as ammonium. So sometimes the students have this question as well, plus 1 or 1 plus is the same thing? Yes, it's the same thing. So please relax about that, but please be careful about charges, okay? So then there is another which is called as OH1 minus, called hydroxide. Then it is MnO4 1 minus, which is called as manganate. And the Cr2O7 2 minus, which is called 2 minus, okay? So it is called chromate. So do I need to keep these all radicals or the polyatomic ions in my mind? Yes, it will be a great thing. It will be very helpful for you while writing the formulas. If you are going to keep this list in your mind. Okay, so I am telling you one very good trick. You may consider it as a trick. So whenever a radical is becoming part of a formula of an ionic compound, that radical must, if it is more than one time, then it should be enclosed in a bracket. I'm telling it very clearly. If a radical or radical is also called as polyatomic ion more than one time as a part of a formula of an ionic compound, it should be in the bracket. Okay, so I'm giving you certain examples. All right, so we were practicing NaCl and CaO. All right, now after this information we are practicing further. For example, Al2O3. Aluminum is a part of group number 3. It has a charge of +3, whereas oxygen is a part of group number 6. It has a charge of -2. So it is cross multiplication and 2:3. So that's why the formula is Al2O3. All right. We are practicing another. So it is sodium phosphide. Na is a part of group number 1. It has a charge of +1. Phosphorus is a part of group number 5. It has a charge of -3. So this is 3 is to 1. All right. So this is how we are developing the formula. Now I am trying to give you some examples from radicals. For example, ammonium chloride. Okay, so ammonium is a radical. It has a charge of +1. Chlorine is a part of group number 7. It has a charge of -1, and +1, 1 is to 1. All right. Now I'm saying that calcium sulfate. All right. So calcium is a part of group number 2. It has a charge of +2, whereas sulfate is a radical. It has a charge of -2. 2 is to 2 means 1 is to 1. All right. You may write 2 is to 2 first and then 1 is to 1. All right. Then there can be another example. Ca3PO4 whole twice. Why the formula is like that? What is the name of this compound? Calcium phosphate. Calcium is a part of group number 2. It has a charge of +2, whereas phosphate is a radical. It has a charge of -3. So -3 and this is this. So it is 3 and 2. So calcium will come for 3 times, whereas phosphate will come for 2 times. All right. So it is much better to keep the formulas of the radicals in your mind very clearly. It will make the things easier. It will tell you that how to write the formula. So in today's lecture, we have practiced and we have learned this thing, that how to develop the formula of an ionic compound. Formula of an ionic compound is playing a very important role while writing the structure, while telling the properties of that ionic compound. Thank you very much. Take care of yourself. In the next class, inshallah, we are going to continue the bonding. Thank you very much.